We're going to talk about the relation of the vascular tissue of the stem and the leaf. So there's some terminology, so I'm standing back so that you can go ahead and take notes about that, but I'm going to tell you what these things are. So the leaf trace is, so if we're looking at how the vascular system from the stem connects to the leaf, there are extensions from the vascular tissue in the stem that extend out to the leaf, and those would be called leaf traces. So these would be going down the petiole. And if you looked at this drawing, this is just kind of diagrammatic, but these would be the vessels that would be coming up the stem, and they are going to extend then into the leaf, and of course they're going to branch out, etc. But these are called leaf traces. And there's another term called the leaf trace gap, and this is a gap in the vascular cylinder that is left above where the leaf trace goes off. So these sympodium, like they're basically a bunch of vessels that are going up, and so they're groups or bundles of vessels. And as a group goes off, what's going to happen is there's a gap then in the tissue. And then that tissue can either be remade by parenchyma cells or remade by the tissue above the apical meristem, might be laying it down as the plant is growing. Basically, it's going to happen as the plant is growing. And so you'll end up having continuous tissue above and below, but right here there will be a gap in the tissue, and that will be filled with ground tissue or parenchyma cells. And that's called the leaf trace gap. The stem trace bundle is the group that is within the stem itself. And then there is a branch or bud trace, and this would be the vascular tissue that extends into the bud. So looking back at this diagram that we looked at before, where they're showing you the growing tip or the apical meristem, what is happening, this is, we were talking about growth before, but you can see that there was a vascular tissue here that's extending off into the leaf. And what will happen is, right there would be the gap, and then what's going to happen is some vascular tissue will be left as it's forming right here for the new bud, which is not really showing in this picture, the bud. And then this would continue to push the apical meristem up as it grew up and made a new phytomere. So basically this is the vascular tissue right here, and it's extending off into the leaf. So this would be the leaf trace. This would be the stem bundle, the leaf trace gap, and this, because it's at the top, it's not really showing you how it extends throughout the body of the plant. Okay, and then there's something that we should talk about called phyllotaxy. This is the arrangement of the leaves that are on the stem. So the most common is what we call distichous or alternate. That is where the leaves are coming off at opposite sides of each other, but you have one below, and then as you go up a little bit, the other one will come up off the opposite side. So this is an alternate leaf arrangement, very common. Another somewhat common one is an opposite leaf arrangement, where you have the stem axis and you have leaves coming off directly opposite each other. Of course, this will translate into branches as well. So branching of because the branches are coming from the buds at the leaf axils, as those branches extend off, they're either going to be alternate or opposite, and sometimes they break off for opposite ones and you can't tell, but if you look at the leaves and look up throughout the plant, just looking up in a tree, you can see the opposite or alternate arrangement most of the time. There's another kind of offshoot of opposite called decussate. It's hard to draw on the board, but what is happening is you have the axis, and then you have the leaves coming off opposite in one plane, and then opposite at right angles on the next one up, and then at right angles on the next one up. So ultimately, if you look down on it, it would look opposite, but you would have four, in this case, like 4 leaves. You'd have 2, and then two going the other way, and then two going the other way. It's kind of hard to explain, but mints do this very, very commonly. So if you have a salvia or a mint in your garden, take a look and see what that looks like. Whorled means that you have more than one leaf coming off at a particular node. 3+ leaves. I drew 4 extensions here. And helical means that they spiral down the stem. And usually they look alternate. So if you look at it, the leaves look like they're coming off alternate, but if you lay it on a table, it won't lay down flat. Whereas if you lay a decussate one, disticus one on a table, it would lay down flat. Okay. Now the other thing that we want to look at is the morphology of leaves, and there's this is something that you'll do more in botany too, but I just wanted to briefly go over it just so you knew like some of the terminology related to a leaf. So a simple leaf is kind of like what we've been talking about, where you have the stem, you have the leaf coming off, and the leaf that's coming off has a little stem leading to the leaf called a petiole. It will have an axillary or lateral bud that is in the base of that leaf, and then you'll have the leaf blade itself, which will include a midrib of vascular tissue going down, and usually that branches off in various patterns. So that's a simple leaf. A compound leaf means that the leaf blade is divided. So I always kind of think of it as each one of these main veins that is coming off the midrib is actually going to become a leaf. So if you look at that, so it would look like there's multiple leaves here, but really it's one leaf, and the way you tell is there's a bud at the base of the leaf. So there's still a stem, a petiole, a bud, and then the leaf blade. In this case, the midrib has a new name because it looks different. It's called the rachis. And this is a once compound. You can also have twice compound. That means that each one of those leaves is now subdivided into mini leaflets. Okay, so these are called leaflets that are the subdivision. So that's twice compound. Okay, one last thing that I want to talk about in this section is the transition between root and stem. And you can go ahead and take a screenshot of this and copy this into your notes, because I would like you to understand this. What I drew here was the tissues that are found in the root. So the root would be epiderm, and then next layer in cortex, endoderm, next layer pericycle, phloem, vascular cambium, and xylem. And then in the stem, what we lose is we're going to lose the pericycle and the endoderm. There is no longer pericycle and endoderm in the stem. And these, the vascular tissue and is going to be branching off. In other words, they're making the vascular bundles. Remember that there's many vascular bundles, so it's hard to draw this in 3D, but basically I would be dividing this cylinder into many. I always kind of think of it like a cheese stick that has, when it hits the surface between the root and the shoot, in other words, soil surface, it's going to branch out around the pith. And I'm going to have many vascular bundles, my fingers being the vascular bundles. And each vascular bundle, of course, is going to have the xylem on the inside, the vascular cambium, and phloem, and then of course in the shoot we're going to have a bundle cap. So the bundle cap fibers that will be there, and of course the pith that exists in the shoot does not exist in the root.